Okay.
Hi, we're a teammate. I'm Patrick. This is Steve, and we got Brandon over here in the video. Our
Hello.
project is the smart poker table, and the purpose of our project was to provide a virtual poker environment for real life poker players. And the way we do that is by using CV to scan player stacks, and then that information is sent to the game state tracker, and then this information is then displayed to the rest of the players at the table for them to see. And now we're going to jump into our individual subsystems, and our overall system will come after that, where we talk about our results.
Name is Steve, and I was in charge of the servo subsystem. The reason why we use a servo is because we can mount the camera on top of it, and then we can rotate to a specific player's position, and then the camera can use computer vision to scan the stack and then update in the game state tracker software. So as you can see, here's a picture of our hardware. On the top is a camera, and then the servo is actually embedded into this box that we 3D printed. So in terms of the interconnects, the servo is directly connected to our Arduino, and then we can control the angle from there by saying servo.rotate to a specific angle. However, that angle that we get is from the game state tracker that's on the Raspberry Pi. And the Raspberry Pi, which has the game state tracker on it, the software will send the angle to the Arduino through serial communication. And the overall flow is the game state tracker will send an angle to the Arduino, so it knows which angle the servo should rotate to. And once servo rotates to that spot, the CV will scan the stack, and then it will send the feedback back to the game state tracker, which will which the game state tracker will send the updated player's position, the next player's position back to Arduino, and so on and so forth. Here's a video of how the servo rotates in real life. Depending on the input from the dealer software, the camera will rotate. Rotates to Patrick. Next player, next player, next player, next player.
To calculate the value of a stack, we use computer vision. We require that stacks of chips are separated by value and therefore by color, then placed roughly in a line at the same distance from a camera on a poker table, as seen in the rendering. This camera will take pictures of the stacks. We also require that poker chips have white checkers against a non-white background color. To scan a stack, the algorithm looks for white checkers in the image. Once it has these checkers, it groups them into stacks based on how close each checker is to one another. It then calculates the smallest rectangle covering all the checkers in a group, and uses this as the stack height and width. Once it has these checkers, it will correct the rotation in the image, and then recalculate the height of the rotated image to calculate the heights of the stacks and convert those into the expected number of chips by dividing by the height of a chip, which was found during the calibration phase. Finally, the algorithm calculates each stack value by multiplying its height and the value of each chip, then summing them to get the full value of the bet.
Hello, I'm Patrick, and this is the player UI. This is the home screen, and as you can see, there's an error message that reads, need at least 3 players to start the game. So, to add players to the game, you go to the Add Delete Player screen. As you see at the beginning of the game, there are no players, and you can add a maximum of 8 players to the game. adding a player to that position, put them at that position on the table. You can also remove players from the game by clicking their name. Each player starts with a stack size of $200, but that stack size can be edited at the stack size of the screen. As you can see, each player starts with $200, but that can be changed. At the chip configuration screen, you can change the values of different chips. We allow a maximum of 5 chips in our poker game, and these values can be changed by clicking on the box. The big blind value denotes the stakes of the game, and that value can be changed as well. And the small blind is always half of the big blind value. The calibrate button is used by the dealer to calibrate the color of the chips to the different chip values. Clicking calibrate will take a picture of the screen, and the dealer will need to place each chip in front of the camera here. After that, the dealer will need to highlight one chip like this and enter that value for each chip value. At the top left, you can see the chip value changing as the dealer is selecting the picture for each chip. At the end, the dealer is supposed to select the designated chip area for where chips are expected to be. After all this is completed, starting the game can begin. Steve and I are now going to explain how our overall system works, and we're going to do this by going through an entire round of a poker game. So right now there's 4 players in the game, and they're seated at their position in the table, and we're at pre-flop. There's currently $3 in the pot because of the small blind and the big blind. So it's Jerry's turn to act. Let's just go through a round by calling. So Jerry will call, get the big blind. Everybody will call, so everybody will be in for a big blind. This information's now reflected in the pot size because everybody called. As you can see, the camera rotates from position to position in case it's somebody's turn to act and they want to raise. So Brandon will check. Pat will check. And then let's say Jerry here raises. Jerry will place his bet in front of the camera right here, and then when he raises, that change will be reflected in the pot. Jerry raised $54, and then that change was reflected in the pot size, which changed to 58. Pretty sure that was 100% accurate. And then let's say who's sitting here. Let's say this player calls, and everybody else folds. This player will need to put his money in for the call. And then the pot has now grown. And let's say they check to the river. Your Pat folds. And then they say they check to the river. The dealer will now need to choose who won by looking at the cards. The dealer will be dealing cards, and he'll pick the winner of the round. And when the dealer selects the round, selects the winner, the stacks will update accordingly.
Lastly, we'll talk about the design trade-offs that we made. So as you can see here on the left, we have a picture of our hardware, and on the right, we have a picture of our entire setup. As you probably noticed in our last demo video, there are stickers around the table, and that is to make sure the distance between the stack and the camera is constant, so that our CV, our computer vision algorithm, can run robustly. Also, on the top left of this picture, there's actually a lamp which we require to hold the color temperature constant. Also, that is for CEV to run more robustly.